Module 3, the best module, and it says events A and B are such that the probability of A is 0.4, the probability of B is 0.45, the probability of A union B is 0.68. Find the probability of A intersect B. The probability of A intersect B, that is equal to the probability of A plus the probability of B minus the probability of A union B. And so what we're going to get is the probability of A intersect B is equal to the probability of A, which is 0.4, plus the probability of B, 0.45, minus the probability of A union B, which is 0.68. We work that out, 0.4 plus 0.45 minus 0.68, and so we get 0.17 is the probability of A intersect B. Now determine whether A and B are independent. Now let's check it. The probability of A times the probability of B, that's going to be equal to the probability of A is 0.4 times the probability of B is 0.45. When you multiply those two together, you get 0.4 times 0.45. You get 0.18. Now the probability of A intersect B is equal to 0.17. Now since they are not the same, since the probability of A intersect B is not equal to, let me write it out. They are not independent pretty much. So since we realize that the probability, yes, I want red, the probability of A intersect B since the probability of A intersect B is not equal to the probability of A times the probability of B, then A and B are not independent. So A and B are not independent events. That's that. Moving right along. This question says, a committee of 4 persons is to be chosen from 8 people, including Mr. Smith and his wife. Mr. Smith will not join the committee without his wife. He's a good husband, but his wife will join the committee without him. Okay, so he's only going to go if his wife is there, which probably means that it's a committee that he doesn't really want to be on, but his wife is telling him, all right, we need to do this, but you know, if she's not going to be there, he's not going to be there. It's probably more of an interest to her than to him. Let's assume that. That's the only reason why she will join without him, but he won't join without her. So calculate the number of ways a committee can be formed. So the committee can be formed. So possible, let's look at case 1. Case 1 would be Mr. Smith and Mrs. Smith on the committee. Let's look at that case first. I know I spell committee wrong, so be it. So if both of them are on the committee, we're choosing those two already from 2 times. We can only then choose 2 other persons from the 6. So that will give us 2 choose 2 times 6 choose 2, which is 15. So there are 15 ways in which both of them can be on the committee. Let's look at case 2. Case 2. Case 2 is Mrs. Smith on the case 2 is pretty much Mr. Smith on the not on the committee. Mr. Smith not on the committee. So if Mr. Smith is not on the committee, but his wife is still on the committee, then Mr. Smith is not on the committee. So he's definitely out. So you're really just choosing the other people. So he's out. So you're just choosing 7. You're choosing 4 from 7. So you're choosing 4 from 7. So 7 choose 4 is equal to 35. And so that's it. And so the total possibilities is equal to 15 plus 35, which equals 50. That's the total number of ways this committee can be formed. Nice and easy, soft. All right, this question says, how many 8 digits greater than 500,000 can be formed with digits 2, 3, 4, 5, 6, and 7 without repetition? Without repetition means we're not repeating any digit. And if we're not repeating any digit, then let's go ahead and look at not repeating any digit. So not repeating any digit would mean we have not repeating any digit, as I said. So that means we're looking at case 1. It must be an odd number. So that means the number ends with 3. Let's look at case 1 where the number ends with 3. So you have 6 digits, 1, 2, 3, 4, 5, 6. So if the number ends with 3, so this has to be number 3 go here. So there's only one way. Now the number must be greater than 500,000. So you can either select 5, 6, or 7 right here. So you have 3 numbers can go here. So now after you take out these 2 numbers, you're left back with 4 numbers. So 4 number can go here, 3 number can go here, 2 number can go here, then the 1 number go there. So case 3 has how many ways? That's going to be 3 times 4 times 3 times 2 times 1, which is 3 times 4 times 3 times 2 times 1. That's 72. There are 72 ways where it can end with 3. Let's look at case 2 now. Case 2, as you rightfully call it, we're looking at the cases where it ends with a 5. If the odd number ends with how many odd numbers are between here? 3, 5, 7. So there are 3 cases we have to look at. If it ends with a 5, that means the first number has to be 6 or 7 in order for it to be bigger than 500,000. as no number can be repeated. So this is 1, 2, 3, 4, 5, 6. So this number here is 5. So there's only one number going to go there, which is 5. Right here, so the number need to be bigger than 500,000. So it have to start with either 6 or 7. So there are two numbers we can put here. After we take out them two numbers here, left back with 4 number. 4, 3, 2, 1. So this will then be 2 times 4 times 3 times 2 times 1, which is equal to 2 times 4 times 3 times 2 times 1. That's 48. And then finally, as you call it, case 3. Case 3 is going to be the case where the number ends with a 7. So if the number ends with a 7, then we have case the number ends with a 7. If the number ends with a 7, then that means right here, so it can't be 7, it has to be 5 and 6. So the number ends with a 7 in this case. So there's only one way for that, then it has to start with 5 or 6, so that is 2. And then this is going to be, how many numbers left back? 4, 3, 2, 1. So again, this is going to be 48. So add them here up and get the total possibilities. So the total ways we can get odd numbers greater than 500,000 without repeating digits is equal to 72 plus 48 plus 48. Add those up, 72 plus 48 plus 48, we get 168. That's the total possibility. Nice and easy, soft. All right. Now part D. Part D gives us a matrices question, and it says two matrices are given as A and B. By finding A times B, deduce that A inverse is 1 over 88 times B. So first thing we do is work out what's matrix A times matrix B. Matrix A times matrix B is going to be row by column. It's going to be 5 times 18 times minus 2 times minus 8 plus 3 times minus 6. You're going to get 88 here. So you're going to get 88. Without even working it out, I can see it's going to be 88, 0, 0, 0, 88, 0, 0, 0, 88. So what this works out to be is that A times B is equal to, if you factor out 88, you're getting 88 times the identity matrix. All right, nice and easy. Now, if you're to divide both sides by A, or rather, if you're to divide both sides by B, let's divide both sides by B. I know you can't necessarily divide matrices, but the principles remain the same. If you divide both sides by B, B over B cancel, and so you get that A is equal to 88 times, no, 1 over b is b to the minus 1. When you're multiplying it by the identity matrix, that doesn't change anything. You can just put I. And then what you get is flip it. If A is this, then 1 over A is equal to 1 over all of this. 1 over 88 times b to the minus 1. And so what we're getting is 1 over A is e to the minus 1, which is equal to 1 over b to the minus 1 is just b. So this becomes 1 over 88 times b. Nice. That's what we get. No, you didn't have to do it like that. It said deduce, it didn't say show. I deduced it. I deduced that by finding A times B, I deduced that A inverse is 1 over 88 times B. Now, you didn't have to do it this way. Let me put a or. A or way would be or. Why is it coming out like this? This is a or. A or is to do what they teach us to do. If you have A times B, A times B is equal to 88I. They tell us to pre-multiply the matrix by A inverse. So you pre-multiply by A inverse, and pre-multiplying by A inverse, you get B is equal to 88 I times A inverse. That's one way. Or another way they tell you to do is pre-multiply by B inverse. Pre-multiply both sides by B inverse, and it works out. So you can pre-multiply by inverse as well. So this takes care of question 5. All right, it says now hence solve the system given as this for x, y, and z. When it says hence, meaning using this A inverse as 1 over 88 times B. So hence, without even looking too deep into the question, you know that x, y, z is going to be equal to 1 over 88 times the matrix B matrix B is given by matrix B is given by 18, 12 minus 1, 18, 12 minus 1, negative 8, 24, 20, minus 6 minus 4, 15. Multiplied by 7, 11 minus 6. All right. So when we multiply these two across, that will give us what x is, what y is, and what z is. That will give us our x, y, z. So multiplying them across, we're going to get this is equal to 1 over 88 times. Row by column. So you just put that in your calculator. 18 times 7 plus 12 times 11 plus minus 1 times minus 6. I get 264. 264. All right, and then you have minus 8 times 7 plus 24 times 11 plus 20 times minus 6. I get 88 here. And then finally, I have minus 6 times 7 minus 4 times 11 plus 15 times minus 6. That's minus 176. So in conclusion, x is going to be 264 divided by 88. So x is equal to 3. You're going to get y is equal to 1. X equal 3, y equal 1, and z equal negative 2. Nice and easy, soft. Nice. Now we go to the final question of the paper, question 6. Question 6 is typically going to be a differential equations question. And so we have this differential equation here. Differential equation, it says, a differential equation is given by y prime times cos x is equal to y sine x plus sine 2x. Show that the general solution of the differential equation is this. So to solve a differential equation, you want to put it in the form dy by dx plus k times y is equal to a function of x. So you have y prime. That's why writing back the question, we have y prime cos x is equal to y sine x plus sine 2x. And so I'm going to just bring over the y sine x to have y prime cos x minus y sine x, and that's equal to sine 2x. Okay, now once you reach this part now, you can divide through by cos x to get y prime minus, when you divide through by cos x, you get y prime minus sine over cos is tan, so you get minus y tan x. And that's equal to, you have to remember that sine 2x is 2 sine x cos x. So when you divide sine 2x by cos x, you get sine 2x. You get sine 2x. All right, so this is what we get. The reason for that is because, let me put a reminder up here, sine 2x is equal to 2 sine x cosine x. And so if you divide it by cos x, then you're really dividing 2 sine x by cos x. That's what you're doing. This is 2 sine x. So now we need to find the integrating factor I. The integrating factor I is equal to e times the integral of minus tan x. So it's integral of e, the integral of minus tan x. And the integral of minus tan x is going to be equal to e to the, when you integrate tan, you get ln sec. So it's going to be e to the minus ln sec, e to the minus ln sec x, which I can bring up this minus 1, and so e to the minus ln sec x is sec x to the minus 1. So that's the integrating factor, sec x to the minus 1. And so the general solution is just going to be y times your integrating factor. So it's y times sec x to the minus 1. But sec x to the minus 1 is cos x. So I'm going to write this as y cos x then. Sec x to the minus 1 is cos x. We put it there. Sec x to the minus 1 is cos x. So that means we have y cos x. Y cos x is equal to the integral of 2 sine x times cos x, but 2 sine x times cos x is just going to be sine 2x. So it's equal to the integral of sine 2x dx. Nice and easy. So when you integrate sine 2x, you integrate sine 2x. When you differentiate sine, you get cos. So when you integrate sine, you get minus cos 2x over 2 plus some constant c, and that is y cos x. All right, so now we have y cos x. Now we need to show that the general solution of the differential equation is y equal to a half sec x minus cos x plus c sec x. So we need to get rid of this cos 2x over 2. And better to put my plus constant as maybe a plus c. Since they're using c, put a plus c. Plus c. So I divide through by cosine. Dividing through by cosine, I'm going to get y is equal to minus cos 2x over 2 over cosine. Now minus cos 2x is the same as 1 minus 2 cos square x. 1 minus 2 cos square x being divided by 2 cos x. Then we have the c over cos x with plus c over cos x. So divide through by cos x, that's what we get. C over cos x, so this is y. Now after you do that division, always remember you can separate the part in the numerator as two separate fractions. So this is 1 over 2 cos x. So y is equal to 1 over 2 cos x minus 2 cos square x over 2 cos x. 2 over 2 cancel, so you just get minus cos x plus c over cos x. Now, y is equal to a half of 1 over cos x. Now 1 over cos x is sec. This works out to be a half sec x. A half sec x minus cos x. And then c over cos x is c sec x. C sec x. Nice and easy, soft. Make this look more like a C. This look like C sec. This look like C sec. So put C. Show that this is a constant. This look like C sec x. C sec x. So there we have it. We prove it. Nice and easy. Soft. Now the second part says hence or otherwise solve the initial value problem. Y naught equals 0. Meaning when x is 0, we're going to get that when x is 0, y is 0. So solve the problem. So solving this problem, when y is 0, x is 0. So 0 is equal to, when you put cost, the cost of 0 is, the cosine of 0 is 1. So this becomes a half. So 0 is equal to a half. Cos of 0 is 1, so that becomes minus 1. Plus cos of 0 is 1, so that becomes plus c. So now we'll make c the subject, which implies a half minus 1 is minus a half, so c equal a half. C equal a half. So the solution to the initial problem then is y is equal to a half sec x minus cosine x plus c sec x, and c is a half, plus a half sec x. This is how we do this question, plus a half sec x. Nice and easy, soft. Now, it says, oh, so we finish this part of the question, soft. So now we go to part B. Part B says, a differential equation is given by y double prime plus 2y prime plus y equal x e to the minus x. Determine the solution of the complementary function. So the solution of the complementary function of this equation, we're going to call y double prime u squared. So we have u squared plus 2u plus 1 equals 0. Now this is known as the auxiliary equation. So we solve the auxiliary equation for the solution of the complementary function. So we can factorize this to get, this is really u plus 1 all square is equal to 0. And so what we're getting is u is equal to minus 1 repeated. U is equal to minus 1 repeated. Now since u is equal to minus 1 repeated, then therefore the solution of the complementary function is going to be, the complementary function is given by, I like to call it yc, and yc is equal to some constant, you can call it, so it's a plus, all right, let me write it better. I'm going to write it how we're used to seeing it. So it's going to be e to the solution times x, so it's e to the minus x into p plus qx. That's the standard form. This is how most of us will be used to seeing it. I was just about to write it as pe to the minus, I was just about to write it as pe to the minus x plus qx e to the minus x, but I'm saying I can't start out like that. This will be the solution of the complementary function. Moving right along, it says, given that the particular integral is this, then determine the general solution of the differential equation. So first thing, give us the particular integral. So it gives us that yp is equal to, yp is a killer, it's ax cubed plus bx squared ax cubed plus bx squared times e to the minus x. So what we're going to do then is find out yp prime. To find yp prime, we're going to use product rule to differentiate this. So we keep the first. So we write back our ax cubed plus our bx squared. So we keep the first. Then we multiply it by the derivative of the second. When we differentiate e to the minus x, we get minus e to the minus x plus we keep the second, which is e to the minus x, multiplied by the derivative of the first. The derivative of the first is 3ax squared plus 2bx. Nice. All right. So what we get is yp prime is simplified to be equal to, I don't even need to simplify that. I'm just going to find yp double prime. To find yp double prime now, we're going to differentiate yp prime. And so we keep the first. So we're going to get ax cubed plus bx squared keep the first. Then we differentiate the second. We differentiate minus e to the minus x. We're going to get minus and minus give us plus. So we get e to the minus x plus we keep the second, which is minus e to the minus x, keep the second times the derivative of the first, and the derivative of the first is 3ax squared plus 2bx. All right, now we need to differentiate this one now, plus keep the first, which is e to the minus x, times the derivative of the second. We differentiate 3ax squared, we're going to get 6ax. So we get 6ax plus, when you differentiate 2bx, you just get 2b plus, keep the second now, which is 3ax squared, plus keep the second, times the derivative of the first. So you get 3ax squared plus 2bx times, of course, times the, so we keep the first, differentiate the second, plus keep the second, differentiate the first. Differentiating the first is timesing it now by minus e to the minus x. So now we're good and we're all set to go. Now all we're going to do is go back around here, and we're going to remember that we have y double prime plus 2y prime plus y is equal to x e to the minus x. That's the equation we will use to solve for a and b. Y double prime plus 2y prime plus y, that's equal to x e to the minus x. And so this takes a lot of concentration. So what I want you to do is, we need 2y prime, so multiply this by 2. You're going to multiply this by 2, you can put a 2 out here and a 2 right here. All right. Now what I want you to do is add up. You're going to have to add these. Yp plus 2yp plus yp prime. If we're going to add them, let's go about doing that. This is really 2ax cubed plus bx squared. So I have 2 of this. I'm going to underline the like ones. I have 2 of this. I have 1 of it here. I have 1 of it here. What does that mean? Ax cubed this plus ax cubed this minus this, those cancel, that becomes 0. That becomes 0. Right? So that becomes 0. I'm just adding all of these 3 now. Adding them. All right? So those become 0. Next now, I'm going to add, because I'm now adding, cancel out those 1. Now I'm going to add with ax squared now. So I have 2e to the plus 3ax squared. I have 2 of this. I have another 1 of this right here. Do I have any more of them? I have 1 more of it right here. All right, so now you have 2e to the minus x plus minus e to the minus x. 2 plus minus this is 1, plus minus this, that cancels, so that becomes 0 as well. That part becomes 0, so what am I left with? I am left with now, I'm just left with, yeah man, we're nice now, because we just left back with this part. Just left back with this part. Yeah man. So we can just put, let's do it around here. So that implies what we're left back with is this part, e to the minus x, 6ax plus 2b, e to the minus x into 6 into 6 what? 6ax plus 2b what we're getting is that this is now equal to xe to the minus x. So we can use this now to solve for a and b. So using this to solve for a and b, we're going to get that. This is really saying 6ax e to the minus x plus 2b e to the minus x. That's equal to x e to the minus x. So what does that mean? That means that 6a is equal to 1. That means that 6a is equal to 1. So that means that a is 1 over 6. And there's no x, there's no other e term over here, because this part equals this, and so 2b must equal 0, and so b equals 0. B is equal to 0. Nice. Now that we find b and we find a, we know that the general solution y is equal to the complementary function plus the particular integral solution. So it's yc plus yp. Now the complementary function we found, it was e to the minus x e to the minus x into, what did we use again? P plus qx. I want to be consistent. P plus qx. And then it add plus yp, this particular integral, but they told us yp was ax cubed plus bx squared e to the minus x. Now b is 0, and so it is just a, which is 1 over 6 x cubed e to the minus x. So it's just plus 1 over 6 x cubed e to the minus x. Nice and easy, soft. So this is 2018, very easy paper, one of the easiest years of CAPE. Really hope this was helpful. Make sure to subscribe, and all the best prepping for your exam.